Hey, how's everyone doing today? As you know, we just finished up a unit where we solved systems of linear equations graphically. What we're going to do today is start exploring algebraic approaches for solving systems of linear equations. Now, the first example that we're going to look at is going to illustrate why, or the importance of having algebraic techniques to solve systems of equations. So let's get started. The directions for this problem read: solve by graphing, state your solutions as an ordered pair, and check your solution. So we have two linear equations, and what we're going to do is we're going to graph these lines, and we're going to look for the point of intersection. The point of intersection is the solution to that system of equations. So let's go ahead and try that out. I'm going to start off with this first equation here, y equals 2x plus 1. So I typically analyze this equation and look for the y-intercept. Y-intercept is positive 1, so I'm going to graph that point. So 0, 1. And then from there, I follow the slope to generate additional points on that graph of that line. So the slope of this line is 2, which I'll think about as 2 over 1. Or we could also think about that as negative 2 over negative 1. So we can have a vertical change of positive 2 and a positive horizontal change of 1, or a negative vertical change of 2 and a negative horizontal change of 1. And I'll illustrate both of those in just a second when we generate this graph. So let's go ahead and do that. So from the y-intercept, I'm going to follow the slope. I'm going to have a positive vertical change, so up 2, and a positive horizontal change to the right 1. From that point, we'll go up 2 and to the right 1 again. And then I'd like to generate some points to the left of the y-axis. So I'm going to go down 2 into the left 1, and then from that point down 2 into the left 1. So I don't have a straight edge large enough to connect the dots here, so I'm going to do my best freehand. At home, you should always be using a straight edge, especially when you're solving systems graphically. So I'm going to label the graph with its equation, so y equals 2x plus 1. So we're going to do the same thing now, except we're going to graph y equals negative 3x minus 5. So again, the y-intercept for this graph is negative 5, so I'm going to go over here and go down 1, 2, 3, 4, 5 units. And then the slope in this case is negative 3 over 1, which is equivalent to 3 over negative 1. So we're going to again start generating additional points for this graph. So I'm going to go down 3 into the right 1, down 3 into the right 1, run out of space there. So now we'll go up 3 into the left 1. 1, 2, 3 into the left 1, 1, 2, 3 into the left 1. And now we're going to connect those dots and try to locate the point of intersection. So let's go ahead and do that. Okay, and I'm going to label that line with its equation, y equals negative 3x minus 5. All right, so what we're running into is one of the issues, or one of the problems when we're solving systems of equations graphically. And if you look here, it's not 100%, or I'm not 100% certain as to where those two lines intersect. I don't know the exact coordinates. So really right now I'd have to make an estimate. So if I look at that, I would say probably negative 1.1 or negative 1.2, and then maybe like negative 1.5 or 1.6 for the x coordinate. So I'm sorry, for the y coordinate rather. So what I'm doing is I'm estimating. I'm not getting an exact solution. And this is one of the biggest limitations for solving a system of equations graphically. If the lines don't intersect at nice integer values, then you're stuck and you're actually estimating the solutions. So here, the actual solution to this system is negative 1.2, negative 1.4, and I check that graphically using Desmos. So again, solving systems of equations graphically has some limitations. One, it's time consuming, so having to build the graphs takes time. The second thing is that the answers that you get aren't always 100% accurate. So what we're going to start to do is to develop some algebraic techniques that, when done properly, are going to give us 100% accurate solutions. And we can always check our answers graphically or algebraically if we want to as well. So that's going to come up in the next couple videos. I hope this one was helpful, and we'll see you in the next one.